Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yeah, so hello everyone. Am I properly audible and visible? Can you please confirm in the chat box? Yeah. So let me share my screen and so I would request everyone to kindly write their names who are present in the stream, and apart from that, just mention me that my voice is properly audible and my screen is also properly visible, so that we can very quickly start. I will be introducing about this series very soon. Let's just wait for a few minutes so that other people could join. Yeah, so I see quite a lot of people online right now. So kindly write your name in the chat box. Yeah, hello Abhishek, how are you? Yeah, so from today onwards, we are going to start a new series. The name of the series is Practice Session for Your SDE Interviews, and the first topic that we will discuss will be binary search today. Okay, so we previously had in the month of December, we did about graphs. Then in the month of January, we completed trees. Okay, and all these were focused upon interview preparation. And in the month of February, we are doing general preparation of interviews. Okay, so let me tell you the schedule of this series. The schedule will be every week on Mondays, uh, Tuesdays, and Wednesdays at 9 p.m. Okay, so this will be the schedule for as of now. Yeah, so yeah, the people who are joining new, can you please write your name in the chat box? It will be very clear. It will be good for me as well. So, and this will be live on the GFG practice channel itself. Okay, so this is about the schedule and what we will cover. We will basically try to cover go topic wise. We will first do binary search, then we will do bits manipulation, then we will do stacks and queues, then we will do arrays. After that, we will be doing heaps, linked list, then we will be doing DP, then we will be doing graphs, and so on. So this series will continue for a very long time because we will be keeping our sessions very short. This will be mostly around 35 to 45 minutes long. We will be discussing one or two problems at max. Okay. Now the entire session will be focused upon solving one or two problems, and we won't be discussing theory like unlike the previous sessions that we had. Okay. So is everyone with me? Hello Sultan, how are you? Yeah. So this is about the session, and so let us begin then. And the first problem that we will be solving today is based on binary search. I hope everyone knows about binary search. I will be giving you a small formal introduction about binary search as well. But let's look into the problem that we will solve. So this is a very famous problem actually, and it's asked quite a lot of time in interviews. This is actually a medium level problem on binary search. Yeah, so let me paste the link of this problem in the chat box. So therefore, you all can follow with me. Hello, Yash. Yeah. So before I begin solving this problem, I will be discussing a bit of theory related to binary search, and then we will proceed. Okay. So and one more request, I would like everyone to keep this session interactive so that it will help me it will motivate me to provide you all with great content. So you all can write your name in the chat box. I see a lot of new people have joined the stream. So you all can write your name in the chat box to confirm your presence. Apart from that, what you can do is check out the link in the description. The description contains the link of the course called Complete Interview Preparation. So this is one of the really great courses at Geeks for Geeks. That would be basically a kind of a capsule course that will help you prepare for your interviews. Okay. So this will contain all the necessary concepts topic wise, and it will also contain every questions, the frequently asked questions in the interviews. Okay, so the name of the course is Complete Interview Preparation, or and in short form it is also called CIP course. Yeah. So you can check this out. Okay, so apart from that, yeah, and we also have a dynamic programming series going on in this channel itself on Thursdays and Fridays, and we do also have a mock interview session on Saturdays as well on 10 p.m. So if you would like to schedule your mock interviews, you can fill up the form in the description as well about that. You can check that out on this channel itself. So this was everything about the GFG practice channel that we are currently having and everything that is currently going on here. So I would all request you to kindly like this session and subscribe to our channel as well. Okay. So does that work for you all? Let me see the comments. Okay, Abhishek, that's great. Yeah. So I would kindly request everyone to like this session and subscribe to our channel. Okay. So let us begin with binary search then. I won't be covering the theory very much in depth. I would just be going on with the important points, and we can then directly jump solving the problem. Okay, because this is not a theory session. This will be focused upon interviews. Yeah. Okay, so does anyone have any idea what exactly are binary search and why do we necessarily need binary search? Binary search and answer. Hello, Chinmay. I will be giving a small brief introduction about both binary search and binary search and answer. But the major focus of today's session is to solve the problem called aggressive cows. Okay, so I have already pasted the link in the chat box. You can check that out. This is a problem. This is actually a type of problem that uh, takes the concept of binary search and answer. Okay, so I will just be discussing a small bit of theory, not much, since this is a session focused upon preparing for SDE interviews. So we will not go in depth of the theory. We will try to cover that much theory which is necessary for solving our question. Okay, so this is yeah. So the first important point here is that binary search is basically a searching technique. Okay. So there is in fact called linear search as well because let's say if you want to search on any particular number in a given array, you can just iterate over the array and try to find that number and use a checking condition. So the complexity of that would be a linear complexity. So what happens in binary search is that it utilizes the fact that you can sort your array, and if an array or any set of numbers are sorted in a particular fashion, you can apply binary search on that array. Okay, and you can then try to do the search operation. Okay, so this is the advantage of binary search, and the time complexity would decrease to log n. Okay, so why login? Let us see that. Let's say you have a array which contains n numbers in sorted fashion. Now you are interested to find whether a particular number x is there or not. So what you do, you just go to the middle part of the array and check whether this number is greater than x, less than x, or equal to x. So if it is equal to x, it means that you have successfully found your number. You can return the middle position of the middle element. If not, let's say this number is greater than x. So it means that x should lie somewhere on this side of the array. If the middle number is greater than x, I am assuming the array is sorted in ascending order. Okay, so in that case, it will lie on this side of the array, the left side of the array. So what you will do, you will now search on the left side itself. So the search space decreased by half. And in case if the array, this element was less than x, so you will search on the right half. So at every iteration, you will either go to the left half of the array or the right half of the array. So what is basically happening is that in every iteration, the search space is decreasing by half. So if the size of your array is n, in the first iteration, your search space would decrease by n by 2, then again n by 4. So what is basically happening is that you are only checking log n number of times. Okay. So within log n number of times, you will be successfully able to find this number if it exists. So that is the unique property of binary search. It utilizes the fact that your array is sorted. Now the second point here is that uh, the arrays which are sorted also follows another property of called monotonicity. Okay, so it is not necessary that you will be only applying on sorted arrays to find a number. It has other application itself. So the thing here is that the search space, okay, the search space should be monotonic in nature. What does monotonic means that? So the search space should be monotonic in nature. It means that it should follow a monotonic function. For example, if it can be an increasing function, it can be a decreasing function, and so on. Okay. So if an array is sorted, it can be sorted in either in increasing fashion or in decreasing fashion. Okay. So this is monotonic in nature. In fact, not just in sorted order, you can apply binary search in any of the monotonic space that exist. Okay. So any doubts still here? Binary search is for solving the problem in log complexity and log complexity. Yeah, yeah. Basically, why and log I just set the example that if you want to search a number x in a sorted array of size n, it will take log complexity. Okay. Now, if you are doing any linear operation inside a binary search operation, it will take n log n. Usually, whatever DSA problems we get, if you are able to identify a monotonic function in those problems, you can basically decrease the complexity from quadratic to n log n. Okay. So, if you are able to identify a monotonic search space, you can decrease your complexity from n square to O of n log n. Okay, so by utilization of binary search. Okay, now the essence and idea of any problem is to understand whether is there any sort of monotonic function you can carve out. Okay, so let us talk about that. So Chinmoy in the chat box was asking that what exactly is binary search and answer. Okay, so binary search on answer is basically, let's say, you are given a problem, normal data structures and algorithm problem. Now you know that your answer would lie between a lower value and a higher value. Okay. Hmm. So your answer would lie between a lower value and a higher value. So basically, what happens here is that if you know this and the this from this lower value to this higher value, this entire function is monotonic in nature. Okay. So in this case, what will happen? You can apply binary search to find your answer. Okay, so this is how you will be utilizing the concept of binary search on a monotonic search space. Okay, so this is how the concept is working here. So, Chinmay, does that clear your doubt? Chinmay, are you there? In fact, the students who have just joined late, I would like you all to write your name in the chat box, and also like our session, and at the same time subscribe to our channel. I just in the beginning of the session, I told everything that we are having currently in our on this channel itself. Hello, Chinmay, are you there? Okay, so let us continue then. So this was about binary search and answer. So now our problem that we are given is actually involves this concept in itself. Okay, so the concept of binary search and answer. Now, why this concept? Basically, what happens in interviews? You won't be asked simple binary search problems. You will be asked mostly concepts related to binary search and answers. So there are many famous problems on binary search and answer. The first would be aggressive cows. The second, there is a problem of similar nature called minimum allocation of pages in a book. Then there is something called as painter's partition problem. So all these problems fall under the category of binary search and answer, and these are the hot favorite topics upon asking upon if an interviewer wishes to ask you question on binary search. Then there is something on finding median of a two sorted array. So all these are solved using binary search. Okay, so these are from medium to hard level questions. So today we will be doing one of them that is called aggressive cows. Okay, so let's read the problem statement then. Let me paste the link once again in the chat box so that everyone else can follow. Okay, so let us have a read to the statement. Now, you see, this is a medium level question, and around 16,000 people have solved this, with an accuracy of around 60%. So, let's see. So, you are given an array that consists of n integers, and now you are also given a so this array is basically denoting the position of stalls. So there are n stalls, and you are also given an integer k, which denotes the number of aggressive cows. Now you're given a task that you are supposed to assign these k cows to these n stalls, such that the minimum distance between any two of them is as maximum as possible. So since these cows are quite aggressive in nature, you want to keep them as separate as apart as possible. So basically, since the number of cows is definitely going to be less than or equal to the number of stalls, so you can place the key cows in many ways. So the and let's say you calculate the difference between every consecutive cows, and the minimum distance should be as maximum as possible among all possible ways you can put up the cow. Okay, so this is the question. So now you are given two integers n and k and the array itself that contains the stalls. Now, if you look at the complexity of this question, so the n is around 10 to the power 5, k is greater than equal to 2, less than equal to n, that is around 10 to the power 5, and the value of the stalls is 10 to the power 9, which will fit in an integer. Now, at first glance, there is no way, there is actually very little possibility that you will be able to understand that this is a binary search question. Okay. Now the first step in order to understand if this is a binary search question or not, you have to see whether there is a possibility you can create a monotonic function on the search space. Okay. So you have to understand basically by breaking down this problem whether this can be created into a monotonic search space or not. If yes, then what is that function? Okay. Then how will that function give you the answer? So if you can answer these questions and create that particular function, then you can very easily apply binary search and get the result. Yeah, I suppose there was a small network issue, but I guess things are fine now. So this was about the statement. Now, how we will solve this? So what we can do? Let us take a example. Yeah. So n is equal to 5, k is equal to 3, and the numbers are 1, 2, 4, 8, and 9. Okay. So let me write the numbers 1, 2, 4, 8, and 9. So is that so? Yes, it is 1, 2, 4, 8, 9. Now, number of cows are equal to 3. The number of cows are equal to 3. Okay. So, let's say that, let's say that you place the first cow here. Cow, okay, so you place cow 1 here. And let's say you place cow 2 here. And let's say you place cow 3 here. So if you place in this fashion, the difference between this will be 3 and the difference will be this and 5. So the minimum of 3 and 5 is equal to 3. So for the first arrangement, your value is 3. Now let's you place the cow 1 here, cow 2 here, cow 3 here. In this case, the minimum will be 2 minus 1, 1. Okay. So let's say, are there any other ways you can place a value? Let's see. So basically, you have to maximize the minimum differences in all possible ways of placing the cows. Okay, so now let's see any other arrangements are possible. Let's say you place cow 1 here, you place cow 2 here, you place cow 3 here. The difference between this become 8 minus 2 is 6 and the difference is 1. But you are only supposed to take the minimum difference. So you will be taking 1. Okay, so 1. So basically I see that 3 is the maximum possible difference that I can get. So my answer will be 3 in this case. Okay, let's see. Yes, the answer is 3 in this case. So, since I told you all that this is a binary search question, we have to basically understand that how can I create a monotonic search space. So, anyone in the audience who would like to say the concept of how we are able to identify a monotonic search space on this question? Anyone? Anyone who would like to tell me? Okay. So let's see how we will do it. So let us say that there is a possibility that you can place the cows. Every cows you can place is consecutively. Yeah. Okay. So let's say you place it 1, 2, and 4. So there is a chance that the minimum difference between any arrangement will be one. Because if let's say the position of the one stall is one and the next stall is two, so the minimum difference that you can get is one. So one can be your answer. And what is the maximum value of the answer you can achieve? So let's say one of the stall has the minimum value, and the next stall that you can present is having a maximum value. So the difference between the maximum position of the stall and the minimum position of the stall can be one of your answer as well. So this can be the minimum value of your answer, and this can be the maximum value of your answer. Now the best part, now the most important part here is to understand that whether that from the minimum value to the maximum value, is it following a monotonic space? Okay, so how we will do that? Okay, now the two things needs to be satisfied. In every condition, in every condition, all k cows should be perfectly placed. If you are not able to place a cow, it means that condition is not valid. So let's say you're trying to place a cow. Let's say you take a distance between these two values. Okay. So there are one, there is two, there is three, there are four, five, six, and then the maximum value. Let me denote it by p. Okay. So you take any particular value, let's say 6. Now you are checking that whether you will be able to place all the k cows such that the maximum of all the differences, such that the minimum of all the differences is 6. Okay. So you place a cow here. You make sure that the next cow you place in such a stall that the difference is at least greater than or equal to 6. Okay. So if you are able to place all the cows by keeping the difference at least 6, then you can say yes, you can actually get one of your possible answer is 6. So if you are able to place all the cows by a value 6, it makes sense that all the cows, all the distances less than 6 will be true as well. If you are able to place the cows, listen to this statement very carefully. If you are able to place all the cows by this distance, having a distance of at least this value, it means that you can basically place all the cows having less distances. Okay. So if 6 is getting satisfied, it means that 5 is also satisfying, 4 is also satisfying, 3 is also satisfying, 2 is also satisfying, 1 is also satisfying. So basically, there is a greatest value up to which you can definitely place all the cows here. Okay. Now after that, if you are not able to place a cow on this fashion, it means that you will not be able to place any other values from here. Okay. So you see that this search space now becomes monotonic in nature. Now all you have to do find is the greatest value up till which the placing of cows are possible. So that will be your maximum value, which can be possible in this. That will be your answer. Okay. Any doubts here? So yeah, once again, I would request all of you all to kindly, those who joined the session late and the new joiners, to write your mention your name in the chat box so that I can follow along with it. And apart from that, what you all can do basically is that let me tell you more about this series for the students who are joining new. So we are having a series called practice session on SDE interviews. We will be going live daily at 9 p.m. on Mondays, Tuesdays, and Wednesdays. Okay, so we'll be taking up concepts and problems and trying to solve them. So the first few days will be binary search, of course. So along with this session, along with this series, we have another dynamic programming series going on right in this channel itself. Then we have a mock interview session. We schedule mock interviews on every Saturdays at 10 p.m. So if you would like to get your interview scheduled at any of the mentors at Geeks for Geeks, you can just fill up the form below. So yeah, and also there is a description for complete interview preparation course, which is available on GFG. You can purchase that course if you are willing to prepare for your upcoming interviews. Okay, so it contains all the important questions for data structures and algorithms, and that course is in short form called the CIP course. You can check the link in the description. In fact, that link is pinned in the comments as well, so you can check that out. Okay, so this was about the course. Yeah. So let us move back to our concept. So now we are successfully being able to identify um, a monotonic search space. Now, how to apply binary search? So what we will do, we will fix our low value. The low pointer will be fixed at the minimum value 1. The high pointer will be fixed at um, the maximum value of the stall minus the minimum value of the stall. Yeah, and before that, we must sort our stall vector. Why? Because if we are sorting our stall vector, it means that we can place our cows starting from the start till the end in a greedy fashion. Okay, so that is necessary to sort the stall vector. After this is done, what we will do, we will apply the usual binary search. While low is less than equal to high. Okay, so we will run this loop, and then we will create a check function as well. Okay, so in this check function, we will pass the number that is the middle value. Okay, so middle will be low plus high divided by 2. So we will pass the middle value to our check function, and this check function will basically tell us that whether it is possible to have a arrangement of k cows such that they are having at least a distance of mid amongst them. Okay, if this is possible, we will return true. If not, false. So if check function is returning true, it means that our search space would become, so our low would become mid plus 1. Okay, and if it is returning false, it means our high should become mid minus 1. Okay, now if it is returning true, it means that it can be a possible answer. So I will just update my answer vector to mid. And if not, then we will just decrement our high to mid minus 1. So I will be implementing both of these functions in a code, and if you that will clear all your doubts. Now this check function. Now this check function is supposed to check that whether you will be able to place k cows or not. So let's say you place the first cow on the first stall. Okay, now the stall contains the least value. Okay, now what you will do, you will try to place the cows in every, you will try to place k cows. Okay, now how we will place? So let's say you place the first cow on the first stall. Now you will check whether the difference of distance from the second stall and the first stall is at least equal to the middle value or not. If it is that, you can place that cow there. If not, you have to move to the next one because you want to keep that minimum value. Okay. So if that the difference between the values of every consecutive stall is greater than or equal to mid, you can place a cow and move on. So after this entire array is done, if the number of cows are over, means you have successfully been able to place all the k cows, it means that your problem is done. Now your check function should return true in this case. Okay. So let us try to implement this. Please use dark background theme. Okay, let's see. Do you want me to use this and write in white? Okay. Okay, let's see. Yeah. Hmm. Okay, yeah, this looks good. So what we will do, we will allocate the, as I said, so let me just repeat it once again. So we will allocate the first cow to the first stall, and then from I equal to 1 to n, we will check for every consecutive difference whether it is greater than equal to mid or not. If yes, then we will increment the value of the cow. And if we are able to place all the k cows, and which means yeah, in that case we can return true, and if not, we'll return false. Okay, so this was about the concept. So let's move on to the implementation. Yeah, just a minute. Let me get the code for that. Yeah, so let me rename the name of our vector to be stalls. So the name of a stall, so let me rename it to A. Okay, so this is n and this is k. So low will be 1, high will be a of n minus 1 minus a after I'm sorted the array. Now this will be middle. Now it's possible I'm sending the value of a, that is a vector, the value n, the number of middle. So cows is basically k cows are there. So let me rename it to cows. Okay, and finally this binary search is working. So low is equal to mid minus 1. So what I'm happy is if this is a returning true, it means that low is equal to mid plus 1. Okay, if this is returning true. Now if it is returning 1, high is equal to mid minus 1. So at the end what will happen, my answer will be stored in the high variable itself. Okay, so I can return the very high value. Okay, so this is how the implementation of this concept will work. Okay, so yeah, let me try to compile this code and see. Yeah, meanwhile, those who have joined late and those who have joined who are new to this session, I would request you all to kindly like this session and subscribe to our channel. That would be very certainly helpful. And apart from that, I will be telling you all about the series after this question gets done. So kindly stay tuned for that. So there is a small compilation error that says that no match for operator A for n. Okay, so what I should do here is that I should this fashion of writing sorting is for arrays and not vectors. So I should write dot begin, and in this case I should write a dot end. Okay, so yeah, so let me again compile this code and check. Hmm, this should be a vector in fact. Okay, so let's see the now. Yeah, as you can see, the compilation is successful, and let me submit the problem. Yeah, so as you can see, all the test cases have passed, so therefore this concept is correct. So this was a problem on binary search and answer. So let me review it once again. So this was the first problem that we did today. We will be doing more problems today, tomorrow, and the night day after tomorrow as well. So this was about yeah. So we are done with today's problem. So let us just let me revise it to you all the schedule. So this is a new series called the practice session on SDE interviews. In this, I will be starting on Mondays, Tuesdays, and Wednesdays at 9 p.m. The session will be around 40 to 45 minutes on average, and we'll be discussing either one or two problems. And I will try to keep the problem from medium to hard level so that you all get a good level of practice for the interviews. So the first 3 days would be binary search, and the next would be bits manipulation. The topics are arranged in this fashion. So everyone who are presently in the stream, I see quite a lot of people. Around 12 people are present. So what you all can do basically is that like our session and subscribe to our channel, because not only just this series, we also have a dynamic programming series going on every Thursday and Friday at 10 p.m. And we also have an interview mock interview session on during Saturday at 10 p.m. So if you wish to like interview schedule, you can check that out too. And there is a course called Complete Interview Preparation, so you can check that out in the link in the description. So if you are if you're preparing for your interviews, and basically that course contains, it's a capsule course, and it will contain all the necessary information that you need to prepare for your interviews, all the uh, uh, all the important questions, the frequently asked question, and all the relevant topics. So you can definitely check that out, and it is one of the really great courses as well, because I have also followed that courses when I was preparing for my interviews. Okay, so that will be really certainly helpful for you all. So yeah, let's see the comments then. Okay, yeah. So see you all tomorrow then. Hello Prakhar, I will be using the dark background theme from tomorrow onwards. And Chinmoy, did you understand the binary search and answer question? You asked me to. So the problem that will be discussed. And tomorrow we will try to discuss the painters partition problem. That is also another binary search problem on binary search and answer problem. Okay. So see you all tomorrow then. Yeah. Bye bye. Have a good night.